Yeah, good afternoon. In the today's class, we are going to see about properties of fluid. So we all know that what is all about fluids. Next, we are moving on to what are the different properties generals for fluids. So generally, property is nothing but for any system, it will have some characteristics. So that we used to define as a property. So if you take a water in a container, so the container we can assume as a system. So in that container, there will be various properties, or the variable which will be present. So the variables which may be present are pressure, temperature, and volume as well as mass. So we can tell these are the variables also called as properties. Here, pressure, temperature, and volume and mass we used to tell as a property. So other properties such as viscosity, thermal conductivity, models of elasticity, thermal expansion coefficient, electric resistivity, and even velocity and elevation also we can add as a property. So the properties is also subdivided into two types. One is extensive property and intensive property. So intensive property is nothing but those properties which are independent of mass of a system. So if you take a system, if if the system is independent of mass, for example, the only variable which are present in the system is temperature, pressure, and density, then we can tell that system or the properties which are specified in that system is intensive property. Similarly, extensive property is nothing but those whose values depends on the size, which is nothing but the depends upon the mass of the system. For example, the total mass, volume, and the total momentum are some example of your extensive property. So this property mainly depends upon the mass. So for here given schematic picture defining showing intensive property and extensive property. So an easy way, this is an easy way for determining whether the property is extensive or intensive property by taking two equal part of imaginary partition. You can see means in each part will have a same intensive property of the original system, but half of the value of the extensive property. If you take mass, volume, temperature, pressure, and density. So if we divide this one, we'll have both intensive as well as extensive property. So the mass and the total volume at a half m and a half v determines the specifies the extensive property, whereas temperature, pressure, density specifies the intensive property. So these are some other properties of fluid which are mainly indulged in the fluid is we can tell density. Density is one of the property. Then specific weight, specific gravity or relative density. Then specific volume, viscosity, kinematic viscosity. Then capillarity, bulk modulus, vapor pressure, then surface tension. These all are also properties of the system. So in that we will see one by one. First, we will see what is all about density or mass density. If you take any fluid, so if you want to calculate the density of the fluid, you need to know both the mass as well as the volume. So in that case, we can easily determine the density or mass density of the fluid. So the unit for mass density in SI system is kilogram per meter cube. So generally, if you see means the density of the liquid may be considered as a constant, while that of gases changes with the variation of pressure and temperature. That's why the density of water is always having a constant value, 1000 kilogram meter cube. Whereas if you take gas, and the density of air is 1.27 kilogram per meter cube. But it will goes on changing with respect to pressure and temperature when you go up or when you go down. So mathematically, we can write rho equal to mass of the fluid by volume of the fluid, where rho is the specific notation for defining the density or mass density of the fluid. As I already told, the value of density of water is 1000 kilogram per meter cube or 1 gram per centimeter cube in CGS unit. So in general, if you take a water and if you heat, so what will happen? The water will tend to evaporate. So automatically the density will decrease. Density will decrease. That's why here we have mentioned for the density of the substance is depends both on pressure as well as temperature. But in case of gases, the density of most of the gases is proportional to pressure and inversely proportional to temperature. So directly proportional. So if the pressure increases, automatically the density of the gas is going to increase. Whereas in case of temperature, it is in reverse direction. Okay. So for example, liquids and solids on the other hand, which are incompressible substance, where the variation of air density with respect to pressure is usually negligible in case of liquid and solids. Then the next property is specific weight of weight density. So it is defined as the ratio of weight of the fluids to volume of the fluid. So generally we can get the weight of the fluid as well as volume from the, we know that density is mass by volume. So from there, if you find out the volume, then your volume will be equal to mass into uh, density. Sorry, mass divided by density. So in the place of volume of fluid, if you substitute uh, mass into, sorry, mass divided by rho. So your expression will be W will be equal to rho g, which is nothing but the specific weight of the fluid is density into gravity. So if you calculate what is the specific weight of water, we can easily calculate here. So we know that the density of water is 1000. So 1000 multiplied by 9.81, we can get 9810 Newton per meter cube. The next property is specific volume. So specific volume is defined as the volume of fluid occupied by unit mass or volume volume per unit mass of the fluid, which is called specific volume. It, in other words, we can tell reciprocal of density is also called as specific volume. Reciprocal of density. It is mainly applied to gases. Specific volume. Next property is the specific gravity, or we may tell relative density. Both are same. So generally, the specific gravity, in most of the cases, if you when you are about to solve problem, if the density value is not given, the specific gravity value will be given. So by using the specific gravity, we need to calculate the density in that case. So generally, if you are going for liquid substance, then the standard density we can take water. So generally, the specific gravity is defined as the weight density of the fluid to weight density of the standard fluid. Weight density of the fluid, the one we are going to calculate, whereas the weight density of the standard fluid. So based on the substance, we need to take the value. If it is a liquid substance, we can take water as the standard density. In case of air, we can take atmospheric air value. So if you for liquid, the weight density of liquid divided by weight density of water. So if it is water, you just multiply by 1000 the given value of the specific gravity to get the density. And in the case of if it is an gas, then you just multiply with the density of the weight density of the standard air, which is nothing but 1.27. So that you can directly get the weight density of the specific density of the gas. So these are some specific gravity for the substance it has been given, where you can see it. Similarly, for the specificity of mercury is 13.6. If you want to determine the density of mercury, you just the standard fluid for is water. So multiply with 1000. So 13.6 into 1000. So 13,600 kilogram per meter cube. So here we will see one problem. So example one, we are about to calculate the specific weight, density and specific gravity of 1 liter of liquid, which weighs 7 Newton. So if you see means first write down the given values, what are the given data which is present in the problem. So here they have just given the volume which is 1 liter. So convert that into meter. So we know that 1 meter cube is 1000 liter. So just convert that one. So similarly, weight is given. Weight is given as 7 Newton. So what are the parameters we are about to calculate means to find specific, we need to find specific weight, then density and specific gravity. Okay. So we know write down the formulas. So we know that weight density is rho W equal to rho g. You know the formula. Weight by weight of the fluid by volume of the fluid. We know the weight, which is 7 Newton. Whereas volume is also given as 10 power minus 3 meter cube or 1 by 1000 meter cube. So the specific weight of the liquid is 7,000 Newton per meter cube. Similarly for density, we know that density is mass by volume. Otherwise, from the specific weight also we can determine, already we have got the specific weight, from there also we can calculate the density. Density, we know that W equal to rho G, so rho will be equal to W by G. Already we have calculated the specific weight, so substitute that value. G is constant value 9.81. So the value what we have got is 713.5 kilogram per meter cube. So this is the density of the given liquid. Specific gravity. So if you want to get the specific gravity, we know the formula: density of the liquid by density of the standard fluid. So the density of the liquid we have already calculated 713.5. Density of the standard fluid, here it is liquid, so we can take 1000 as the standard liquid fluid. So 713.5 by 1000 is around 0.713. So just do this problem as an assignment. Calculate the density, specific weight, and weight of 1 liter of petrol of specific gravity. Specific gravity is given. Then we are about to calculate the density, specific weight, and weight of 1 liter of petrol. So volume is also given. So by using these two values, calculate the density, specific weight. It is a small problem. We can do it. Coming for the tomorrow class, you just solve this problem. Next property is the viscosity of the fluid. So we all know that viscosity is nothing but the measure of resistance. Okay. So generally, if you take any substance which is having viscous, if you take water and oil, pour it down. So which fluid will move faster? So generally, we all know that water will be moving faster compared to that of the oil. So it seems that the oil has higher viscosity, so it resists the movement of one layer of fluid over another adjacent layer of the fluid. Okay. So generally, how we can elaborate this one means, if you take um, it just consider a pathway where the water is flowing. So the layer which is adjacent to the solid surface will be having a zero velocity. Okay. So when you increase the layer from the downwards to top, the velocity of the layer increases. Okay. So what will happen means, generally, the higher moving layer will try to attract the lower moving layer. So the lower moving layer will try to attract the faster moving layer. So when there is an attraction between the two layers, or intermolecular force attraction between the two layers, so there exists the viscosity. The movement of the fluid gets resisted. Okay, that we are telling in viscosity. Here you can see the diagram showing the velocity profile. So the bottom surface, where we can assume that is in the solid surface. So y is the distance from the bottom surface to the top surface. Dy denotes the distance between the two layer, where we have chosen two layer, where the velocity for one layer is u plus du, whereas for the other layer is u. So the difference between these two layers, the difference in velocity is du, whereas the difference in distance is dy. This diagram shows the velocity profile or velocity variation near to the solid boundary. Generally, if any liquid layer which is adjacent to the solid surface, due to adhesive force, that layer will be attracted to the solid surface. So the liquid layer will possess a zero velocity. So when the layer increases from the solid surface, the velocity also slowly increases. That's why we are getting a curve that shows the velocity profile. So here, from this, based on this equation only, we derive the Newton's law of viscosity. That is Newton's law of viscosity. So your shear stress is directly proportional to rate of change of velocity, where du by dy is the velocity gradient, tau is the shearing stress. So generally, it has been told that mathematically tau shear stress is directly proportional to du by dy. Your shear stress is directly proportional to velocity gradient or rate of change of velocity. So in order to remove the proportionality concern, we are taking a constant notation which is mu, which is called as proportionality constant dynamic viscosity or coefficient of viscosity. So tau will be equal to mu du by dy.